Are you a developer and have you lived the dependency hill in software development? Many times in software development, coders get into a so-called dependency hell, figuring out the working versions of the dependencies of the models in the source code with one another is one big unproductive moment that happens from time to time. Instead of focusing on meaningful, visible business logic, we developers are often fighting the tech stack itself, trying to figure out how things are working while they are connected between each other. From one hand, there there are source code repositories that a lot of times are the reason some technology is successful because when you developer as if when you are requested a feature, you have where to look up for a bank of features so you could save your time and use some public open source library. Unfortunately, many times there are newer versions of all libraries that are not all working with one another correctly, so things break. And trying to figure out which version of one library will work with what version of another library when both are bumped is no easy task to figure out things. So other aspect is the endless and continuous development of all software. All software components are updated and updated, so many times packages switch structure, switch change APIs, deprecate APIs. So here I'm gonna point out few platforms that I have seen myself over the years. For first, Java. The Java programming language has two major dependency systems, Maven and Gradle. They have their own settings for Java version, for building the project, the for project organization, for dependency repos and settings. So problems start to arise with the Java software when two or more modules depend on a different version of the same package. One solution that I have seen over the years are the OSJ and the Jigsaw frameworks. So they try to fix things. For example, Eclipse IDE is based on OSJ, on Felix, I think. Felix implementation of the OSJ framework. But they have probably resolved all this technical dependency and modularization on a corporate on a level with big projects, but I have rarely seen some starting project, some bootstrapping project being developed with these uh, frameworks, these libraries in mind from scratch. So next thing I'm gonna point out JavaScript. JavaScript has npm dependency management. The hard part of npm comes that JavaScript is interpreted language, so bugs may appear at runtime in their edge cases on edge platforms and on edge on custom settings of the operating system or the browser that they are running on. For example, in year 2017, tried React Native, but it was dependency hell. There were problems with the version of Node.js. There were different versions of the dependencies, so they may have improved, but I am not going back at React Native for now. So Android. Android sits on top of Java. It is using Gradle as a build system, and the problems are resolving, and the problem is resolved in many times because it is more modern. It tried to grab the fixes from the dependency hell, but Android itself as a platform introduced several things that are specific to Java. So there are new libraries for dependency injection that when mixed up with the other things, the integration of code generation and other utilities, the view and code binding because of the XML based binding that the legacy XML code binding, the mixing too much Java and Kotlin is also another breaking stone. I, for example, have a tool that generates ORM data access classes and models, and I have abandoned one of the ORMs because of cannot be resolved status of incompatibility of calling reflection on data models. So another aspect is migrating the package, the support package, from support to Android Hex. So this also introduced problems, especially with legacy projects, and if you mix all these things together, the Gradle build starts slowing down, your CPU goes up, your memory consumption goes up, so and it creates problems in the intermingle of all this dependency injection, view binding, different library components, and it's no fun. Well, the next thing I'm gonna point out is Flutter. So Flutter is a cross-platform framework for creating cross applications for mobile platforms, for web and for desktop. So it sits on many chairs. The Dart language itself has its own pubdev source code repository with packages with many problems resolved. So because it is so new, having dependency hell from pure Dart perspective should be rare. But if it is if it was only Dart, if it was only itself, it would be similar to Java, but better because of the new times that we are now. But unfortunately, in many Dart packages and in Flutter itself, many times it depends on all native platforms in their own problems. And Flutter inherits the problems of the all native platforms or the platforms that it sits on. So, for example, it, it sits on iOS problems when building on Apple platform, like fixing the signing certificates, like dependency is native dependencies, like Cocoa libraries and permissions and other custom Cupertino stuff. So the same is true for Android uh, packages that Dart packages that are depending on native Android code. The same is true. They inherit all the potential problems from Android. So the desktop is the desktop support of Flutter is currently a baby, most of them, and you should await compatibility issues, which is probably okay since they are still in very early age. So many of these new platforms also try to code generate some of its code, so probably there will be same problems as on Android when mixing code generated code with your code and with other libraries, with code from other libraries. So the web has also JavaScript, Node.js server side, and browser compatibility issues. So Flutter, in especially in the browser, will inherit the problems from the browsers, from the JavaScript environment, and the imperfect and in progress development of WebAssembly also. So above all that, Google team introduced new null safety in the language. So now there are endless number of legacy projects that are and setups that some of them are migrated to null safety and some of them are not. So if you feel adventurous, you could also try to use some non-master of non-master channel of Flutter, like using the dev channel or the beta channel, where things are seeming obviously not 100% polished. So if you feel adventurous, you could mix uh, development channels of Flutter, no safety, some platform different from than iOS and Android, which are newer, and you could go nuts with mixing all this stuff. So good luck escaping the problems that are and being able to focus on pure business logic and algorithmic stuff that is meaningful for your users than fighting demons of beneath the bed of the source code.